Problem 4-25. Ted needs to find the point of intersection for the lines y equals 18x minus 30 and y equals negative 22x plus 50. He takes out a piece of graph paper and then he realizes that he can solve this problem without graphing. Explain how Ted is going to accomplish this. Then find the point of intersection. An important part of this, we're finding the point of intersection because we're finding the solution to a system. On your previous 3 homework problems, you were just finding solutions to equations there. You turn them into functions or turn them into systems. Now you're doing the opposite. Now you're actually finding the point of intersection. So we need to come up with a coordinate, x and y. So in order to solve this, yeah, we could take it, we could graph it on here and then find that point of intersection, but he just said that he can do it without graphing. So let's figure out how he's going to do that. We write down the information we have, y equals 18x minus 30, and he's got y equals negative 22x plus 50. Well, if this expression equals y and this expression equals y, then we know that these two expressions have to equal each other because we know y would equal y. Let's rewrite this now then as 18x minus 30 should equal negative 22x plus 50. Just using substitution. Or if you took the CPM Algebra 1 course, I think we called that the equal values method as well. So let's solve this the rest of the way. Let's do plus 22x plus 22x. And I'm also going to go ahead there and I'm going to add 30 to each side there. If you want to do it as 2 steps, no problem. I'm just trying to save time because I am recording the video here. So we end up with here 18x plus 22x would be 40x. And negative 30 plus 30 is going to be 0. So we have 40x equals negative 22x plus 22x is 0. 50 plus 30 is 80. Well, 40 times what number is going to give us 80? We know that we should end up with 2. So x equals 2. Now that's the solution to this equation right here, but we're trying to find the point of intersection. So we know that when x equals 2, we need to also figure out what the y value would be. Let's take that 2 and plug it in. We've got y equals 18 times 2 minus 30. 18 times 2 is going to give us 36 minus 30. So y equals 6. So we've come up with the point 2, 6. When we plug in 2, we should get 6 out. Let's check it with our other equation just to be safe. I'm going to put my 6 in for my y. So I have 6 equals negative 22 times 2 plus 50. Negative 22 times 2 is negative 44 plus 50 should give us 6, and we get 6 equals 6. We know we are correct. So the intersection point would be the point 2, 6. And Ted was able to accomplish that because he listened to us and we solved it using substitution or the equal values method for solving systems of linear equations. And you can go ahead and stop watching now if you want. I'm just going to check it on my calculator real quick as well. I'm going to type in each of my functions, y equals 18x minus 30. And y equals negative 22x plus 50. I'm going to graph them. And I see there my intersection is going to be somewhere around there. It's kind of a messy looking graph, but if I want to take it here, I could always go in and shrink my window a little bit here to make it so it makes it a little bit wider. I'm going to do -5. And I know my solution is already 2, 6, so I just need to have a number greater than 2. Let's go ahead and make this a +5 for our maximum value for our x. And for our y's, let's see here, we know our intersection point was at +6, so I think we'll actually be all right with our y's. Let's go back and look at our graph and see what we've done there. Now we can see it a little bit more clearly. So if we want, we can go through and do our intersect function there. So remember that comes from the following key sequence. We go second, trace, number 5 for intersect. We got to mark each of our curves there. So we've got enter, 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 and it gives us the intersection point was at 2, 6. We already have that. We know that we are correct. And everything is good to go. This is problem 4-25. If you have questions, make sure you ask your teacher. Other than that, have a great day.